to vote. Just, I need to select the right window.
Hello everyone, welcome to PCE. I'm John, this is Julien. We're going to get started now. It's 20 past 3, so you can take your seats. Okay, so we'll start with a note well, as we always do. Please note well that this is an IETF session. By participating in the IETF, you agree to abide by its processes. Anything you say in this meeting is considered an IETF contribution. You agree that the meeting may be recorded, etc., etc. You can read it all. Okay. So this week at IETF 98, there are 2 PCE sessions. First one is right now. It's our usual PCE working group meeting. The second one is going to be on Friday at 9 a.m. This is the joint session with jointly with TEAS and MPLS and CCAMP to discuss Yang models related to our general area. So if you're interested in Yang, then please don't leave town. Please stick around for Friday. So please, could we have minute takers? If you're able to take minutes, that would be excellent. Anyone who's keen on doing that, please head over to the Etherpad. I'm also on the Etherpad. So what you need to do is find the PCE agenda on the IETF website and click through to the link for Etherpad minute takers from the sort of main IETF HTML agenda. Is anyone in the Jabber room? A few people. Okay, guys, if you see questions or activity in Jabber, please be prepared to relate to the mic if you could. That would be great. Thanks. We are streaming audio and video. Please speak only using the mics. Please state your name before you speak so that the people listening in can hear you. If you're presenting, please stay inside the pink box so that the cameras can pick up your lovely faces. And yeah, we have a packed, yeah, go on. We have a packed agenda. A few drafts fell off the end, so we didn't have time for everyone's requests. But we did prioritize according to what had discussion and new work coming in. So please consider, if you're going to make an agenda request, it helps your cause if there's been some activity on the mailing list prior to that. Okay, so there's our first slide, and the next slide is our agenda. So as I say, it's pretty full. Anyone want to bash the agenda? Nope. Okay, so we'll proceed to working group status. Using the mailing list, there's nothing particularly driving me. It's just the usual nag that I always do. Please use the mailing list actively to discuss all the drafts that we're working on. It's kind of unhelpful if private conversations happen and then new versions of drafts get published, because it's kind of hard to see the process by which we reach consensus. So please, if you have a comment on a draft, please remember to copy the mailing list on that comment. Okay. So our document statuses, we have one new RFC, RFC 8051, the stateful PC applicability. It's published shortly after the last IETF meeting. We have 2 internet drafts in the RFC editor's queue. Both are missing a reference to stateful PCE. So we've got the PSEP service aware and the interlayer extensions, both ready to go, just waiting for stateful PCE to catch them up. With the IESG, we have stateful PCE and stateful sync optimizations. The stateful PCE has been approved. It's pending a document update. The authors have indicated they'll update the document by the 1st of April. I'm assured that's not an April Fool. So we're hopeful that that will get done in the next week. The stateful sync optimizations has just been updated following IESG review, and I see it's been submitted and approved for publication. So thanks for that, Deborah. And then finally, with the IESG, there's PCE-initiated LSPs that's currently pending a routing directorate review before we proceed to IETF last call. So within the working group, there are a bunch of drafts which are at a fairly advanced stage. So we'll go through these one at a time, just give a quick update. First of all, GMPLS PSEP extensions, as past last call, is very mature, possibly a little overripe, and is pending a Shepherd's report. Is that's fair? Okay, so as soon as that's done, then that will get pushed to the ISG. PSEP-S, we promised specifically a status update on this. So we now have a document shepherd, Cyril, who is not here, I don't think, but Cyril has stepped in to be the shepherd of that. He's just reviewed the draft. He's sent some comments to the authors. Drew's nodding his head, so you must have seen those. So I guess Cyril needs to see a new version of that draft, and he will prepare his shepherd's report in parallel, and then we can forward that to the IESG as well. So we'd all be very keen to see that published. WSON RWA extensions draft is stuck waiting for the GMPLS extensions. Otherwise, it's ready. We already have a shepherd's report written, thanks to Daniele, who has been our kind shepherd for that draft. And finally, RFC 6006 BIS, the point-to-multipoint draft, the fix to that RFC, as passed working group last call, and I expect to be sending that to the IESG very soon too. Have we got draft authors for the inter-area AS applicability in the House? And if so, do they want to give us an update on that? No? Okay. So, I mean, the status for that was that we passed working group last call. I was shepherding it, and I had a review and had a lot to say about it. So I think we need to see, I mean, it's mostly editorial stuff, but we need to see a new revision of that draft, I think, before we can take it forward. Okay. So not on the agenda this time, but we have two IDs related to PC association, LSP associations, diversity and policy, and the stateful PCE auto bandwidth draft is also a new ID. And RFC 6006 BIS, that's an error. Well, it is a new ID, but it's already in beyond last call. So, anyone got an update on any of those first three drafts for us? Okay, so I guess they're fairly static. And then we have a whole set of kind of middle of life drafts. We're sort of looking to see, you know, which ones are going to proceed, if any have fallen by the wayside. So is anyone in here who has any knowledge of the state of, let's pick one at random. Jeff.
Apologies for not finishing segment routing. I'll finish it this week. Drew is here as well. So.
Okay. So yeah, just to remind the authors, and I am one of the authors, so I'm reminding myself, segment routing and LSP setup type have an early allocation from IANA. That's going to expire in August. We need to publish by August, or we lose the code points. So let's get it done. Okay. Drew.
Hi, Dhruv. This is regarding the PC P2MP. We will wait for RFC 606 BIS to get over, and apart from that, we have an implementation and we feel it's stable, so we can progress that as well after that. Thank you.
Thanks, Drew.
One more request. We are discussing with the association group object because there are a bunch of documents dependent on that. So I think we have to prioritize that document as well.
Okay.
This is Young regarding stateful PC GMPLS. We're going to revive it and then update. I think Shan left from IETF, so It's been
Yeah.
tracking for a while, but we'll definitely help.
So someone's going to take the reins from Jan and
We may still keep her name, but depend on what she wants. But
she's
definitely-
handing the pen to someone else.
Right.
Yeah.
Okay.
Okay. Thanks.
So I think we're done with the working with status. We'll move to the first presentation. Stefan, please.
Let's wait for the slides.
Show that here.
So I think the first one is about diversity.
Yeah.
Okay, so this presentation is to give you an update on the changes that we done in the association diversity. So just to remember, so the overall goal of this extension is to provide the ability for a PCC to tell the PCE that a particular LSP is belonging to a particular disjoint group where multiple LSP could be. So this is the global ID. So we are reusing the base association group draft, and the ID is to use a particular association type to tell this is a diversity that we want to achieve. So compared to the previous version, so in the first version, we used multiple association types, so one for each disjoint S type, whatever it's being disjoint S or SRLG disjoint S. And based on the comments that we received on the list, so we moved to a different type of encoding. So now we have a single association type, which is path diversity, and we are encoding the diversity flavor in some additional TLV. So this is the TLV that we are using. So it was already detailed in the previous version, but we changed slightly the flags. So it is called the disjointness information TLV, and we are using an encoding which is aligned to what has been done for the SVEC object. So we have a pair of flags for SRLG node and link disjointness, and we are keep using the shortest path bit and strictness bit that were already detailed in the first version. Based also on the discussion, and I think it was a comment from Adrian about how we can couple this with an objective function. So we give now the ability to add an objective function TLV within the association group. So what we are proposing, but we can discuss this option, we propose to use the OF list TLV, which is already existing, but we want to limit it to just a single entry. Maybe we can find a more suitable option, but reusing the OF object was not really good. So this was the option that we are taking for now. And regarding the OF functions, we are reusing the one that have been proposed in the draft from Drew about OF functions for diversity. There was also some detail requested also by Adrian, I think, about what is the exact meaning of this shortest path bit. So we added a dedicated paragraph for this. So the global ID is to tell for one or more particular LSP in the group, I want absolutely to use what we call the shortest path, but the shortest path is in fact the path that is taking into account all the constraints of the LSP except the disjointness. So this means that this particular SP with the p-bit set will take into account all the constraints except the disjointness, and all the other LSPs will be disjoint from this one. So this is the global meaning, and this is clearly a need to provide some one path which is really optimal for some customer. Otherwise, if you don't control the disjointness, you may have two complete non-optimal paths. There was also some request to deal with the case where the PC is not able to find a path, or also it can provide a path, but it can relax the disjointness constraints. So it's possible, for example, when we are setting the S bit to 0, so the disjointness constraint is not strict, so the PC is able to relax it. So what we are proposing is, I think it's the next slide. So in case the PC is not able to find the disjoint path, so we are reusing the no path vector TLV, and we are defining 2 new bits within this TLV. So one to indicate that it's not possible to find a disjoint path, and one which is it cannot compute the path because it does not have the requested algorithm. So for example, we are requesting an SRLG disjointness, and it is completely not able to do it from an algorithmical point of view. And regarding the constraint relaxing, so when the disjointness cannot be found and the PC is providing a path which is not disjoint, so we need to inform the PCC that this path is not completely fulfilling the constraints. So we are proposing a new relaxed constraint TLV, which is more generic, so it's not only tied to this disjointness constraint. It may be used in other use cases where a particular constraint is authorized to be relaxed. I think we need some discussion on the encoding of this. So what we are proposing today, but it clearly requires some discussion, is just to put the object that has been, so the object corresponding to the constraint that has been relaxed. So this is the first proposal, but I think we need some discussion on this encoding and proposal. So about the next step, so we think that we addressed the comments that we received. There's clearly a need for some discussion and enhancement about the new proposal, so feel free to give your feedback, and we'll be welcome to update the document.
Thank you, Stefan. Any feedback, comment, question? No, everything was clear. So in that case, I propose to move to your other presentation.
Yeah, so the next one about state synchronization between a PC. So the goal of the document is first to define the procedures for stateful PC communication between 2 PC nodes. So because the stateful communication has been defined from a PCC to PC point of view, but we don't have the exact procedure for a PC to PC communication. So this is the goal. And why doing this? One of the drivers is to bring more resiliency in the design. So in case I have some PCC to PC session failure, I may be able to send some state using this inter-PC communication. So this is one of the primary goals. And the other topic in this document is to deal with path computation optimality, and also some computation loop scenario where you are falling into some split brain and you have one PC computing one LSP, one PC computing another LSP, and the two LSPs are linked to each other. So for example, the path of one LSP is depending on the other. You may fall into computation loop, and we are proposing some master-slave behavior between the PC in this kind of situation. So the big work that has been done from the last time is we merged with some existing proposal. This was a proposal from Drew about LSDB real-time synchronization. So we have something now which is aligned, and we have a single proposal for all the inter-PC stateful communication. It's also include part of the hierarchical PC, which will be based also on this extension. And we done some slight changes in the procedure. So globally, in terms of capability, we still have a bit to signal that this is a particular inter-PC stateful communication. When the session is set up, both PCs will behave as a PC and a PCC at the same time. So we will have a bidirectional synchronization. So each PC will synchronize the LSP. It's an asynchronous process, so yeah, there is no particular order here. And the idea is that to identify the original PCC address, we are relying now on the speaker identity TLV, which has been already defined. So we are reusing this TLV to carry the original PCC address in all PSAP messages. So now, how does it work? So globally, from a LSP state synchronization, so when a PCC receives a particular state through the PSAP report message, whatever the state of the delegation, it will forward it to all the PC using the state sync session. And the important rule is that we do not authorize a PC to forward a PSAP report message to another PC. So this is primarily to prevent message loops, and it clearly simplifies the design. So when the PC receives from a PCC, it can send to a PC, but when a PC is receiving from a PC, it will not send to another PC. Based on this, a particular LSP state may be received by multiple sources. It may be received directly from the PCC, and it may be received also from another PC or even multiple PC. We decided, at least we propose, to only keep track of a single state. So we just keep in memory the last state that we heard, because from a network point of view, there is a single state, which is the state that has been advertised by the PCC. So it does not really make sense, at least from our point of view, to keep track of all the states. What is important to track is the sources of the state. So we keep one state, but we keep track of all the sources where we learned the state from. So this means that in case, if I want to remove a particular LSP state, I need to have this source list to be empty. So I need to receive a remove from all the sources that provide me this state. Now, the last point on this draft is what we call the sub-delegation. So this is the master-slave behavior that I introduced in the beginning of the presentation. So globally, to solve this path computation optimality, sometimes I really need to have a single PC computing a set of particular LSPs that are working together. If multiple PCs are trying to compute path for this set of LSP, let's say PC1 computes path for LSP1, PC2 computes a path for LSP2 that are really working together, we may fall into computation loop or some path optimality. So in order to solve this, we want to ensure that for this particular group of LSP, we want that one PC will perform the computation. So what is proposed is that when a PCC is delegating an LSP to a PC can decide to sub-delegate the computation to another PC. So we are just defining in this document this sub-delegation procedure, but this election of master-slave is completely out of scope. It could be a manual configuration telling that this particular LSP must be primarily computed by this PC that has this IP address. It can be done by maybe a protocol extension, but this is out of scope. What we are defining here is this just master-slave behavior where when a PC receives the delegation, it can decide to sub-delegate it to another PC. And when this PC sub-delegates the LSP to another one, it loses the control on the LSP. So by itself, it cannot compute the path anymore. It cannot update the LSP anymore. It will be the role of the master PC. So how does the update work? So globally, the master PC will be responsible of the computation. for the LSP of the set of LSP it is responsible for. It will update all the PCs with the difference that for the PC that perform the subdelegation, it will set the delegation flag to 1, and for the others, it will set the delegation flag to 0. Why are we sending an update towards the other PC? It's just to speed up the state synchronization. Because if we don't do this, we will need to wait for the PCC to receive the update and then propagate it back to the PC. It can work, but if we are updating all the PCs from the start, it will be faster. That's just the goal. And after, it's a question of cascading PC updates. So when the slave PC is receiving the PC update, it will see in the speaker identity TLV that this is an update for a particular PCC, and it will relay the PC update to the original PCC. So this extension is also a base for the hierarchical PC stateful work. So if you want to do the hierarchical stateful PC, you will have to advertise this inter-PC capability. And in addition, you will add the hierarchical PC capability. And this is detailed in the PC stateful HPC draft. When we built this architecture, we thought about first message loops that we try to avoid by this kind of split horizon mechanism between PC. But we also thought that it may be optionally interesting to record some information when the messages are propagated through multiple hops. So we are proposing, but it's purely an optional behavior, that each PCEP speaker may add in a new TLV some PCEP speaker information. So for example, its IP address, or if we want to, I don't know, record some particular information on, yes, this is something that we can do. So just a summary. So this is clearly a need for us to have this inter-PC communication to enhance the resiliency, solve the path computation optimality, and so on. I think we are now on the good track with this standard inter-PC procedure, whatever it's hierarchical or flat or whatever. So yes, it's clearly more generic now, and we would like to request the working group adoption for this document. And if you have any feedback, good or bad, feel free to give us.
Any comments in the room? I see someone standing.
Andrew Logan on Nokia. Can you back few slides up to the time when you're talking about how we select the single state?
Maybe
so you're
this
saying
one.
that, yeah, we say we keep a single state, the last one learned. The last one learned is not necessarily the current state. So why you assume that the last state is actually the state of LSP in the network?
Why it could not be the
Different propagation via different paths between.
Yes.
So PCC sends to master, PCC sends to slave, the message to the slave somehow goes faster.
Yes, but the state, whatever the order of the message, the final state that you will have will be the state of the PCC. Because the PC are not changing the...
We can
do you mean in case... I see.
If you have a flapping...
Yes,
yeah,
yes,
flap,
in case of flapping.
Regular,
Yes,
no
in case
problem.
of flapping.
But if we start flapping, this may get out of sync.
I
think we may need to do a little bit more.
Yes, we thought about this, and one of the ideas that we add is for the PCC to add a kind of timestamp.
Yeah.
this was an idea that we have in mind to try to solve this.
Yeah, yeah, we
It's
can-
not in the document yet, but
Okay.
if you also think that it's an interesting
Yeah, like, yeah.
point, we
need to
can
add
add it.
something. Okay.
Thanks.
Thank you. Any other comment?
Okay, Robin from Huawei. Since I think that this is truly interesting the solutions, but from the my point of view, I have some the doubt about this one because I think that in the application scenario, once this connection between the PCE and the PCC is broken, for the PCC, in fact, it's harder to determine if the PCE one is active or is restarted. Can you check more point? Because maybe is restarted is not is the broken of the link. So, and I'm not sure because only the PCE maybe work, but in fact, the PCE and PCC a lot of other links for the some of the BDP or netconf and some of the state need to synchronization, but only the PCE work. I'm not sure the effect is okay for the in the whole the picture. So that's my.
I'm not sure to understand your point, but if, for example, here the PC is completely failing, it's not an issue. If it was a master PC, this one will take over and it will compute the path.
Oh yeah, yes, but my in fact my comments is that the scenario maybe more complex than we assumed, since is in the different application scenario and also the PCE and the PCC.
What is sure is that you will never be able to solve all the kind of failures because you can find some multiple failure scenario where you are losing this session, and maybe this one. And in this case, yes, your computation will not be fine, but yeah, you can try to enhance by bringing more PCEP session, but at a certain point, you will never be able to cover all the failure cases.
Okay, I will check. Okay, later we'll more many list for discussion.
Sure.
Could we have a show of hands from people who read the document, please? Not so many.
Please read the document.
Yeah. Because when we exclude the authors, there aren't so many. So I think it doesn't make much sense to build the room further today. But there is some interesting work in there. It seems to address a missing feature from the PCEP toolset. So please read the document, share your feedback using the mailing list. And thank you, Stefan, for your presentation. Next presenter is Shantaya, I guess.
While we're waiting for the next presenter, could I remind anyone asking questions, it's a good idea to go to the Etherpad and make sure that we capture your question and the response correctly. Otherwise, we may miss some subtlety. Thanks.
So I'm Chaitanya. Yeah, this one talks about the capability for a PCE to request control of an LSP from the PCC. We'll go over a few use cases and then the proposal on the table. So I'll just skip the slide. We've talked about those use cases in the next slide. So more operators are moving towards the centralized TE-SDM control and also looking for new enhancement. And one such enhancement was option. And one such enhancement is for the PCE to take control of an LSP for global optimization. We've got there's some scenarios where the PCE has a better view of the network in terms of futuristic demands, service demands, and this draft talks about the ability for a PCE to take control of a specific LSP, optimize it, and then maybe return it back to the PCC if needed. So it's a very straightforward draft. So we're mostly looking at global optimization of LSPs, the PC able to control some specific LSPs in the network. We've got a few other use cases also defined in the draft. One such one is the PC load balancing cases, where you could have a specific PC request a subset of the LSPs, and they can load balance across multiple PCs to be able to optimize some LSPs in the network. And also the failure cases where if I lose a PCE, the neighboring PC or the standby PC could always request access to optimize a specific LSP in the network. So going back to the proposal, the straightforward proposal, what we are proposing is a control LSP control flag set as part of the SRP object. So it's going to be part of the update message, and a PC sets the flag 1 to indicate that it wishes to control gain the control of the LSP. And this is identified by the LSP object. So it's a very straightforward draft. So asking for a new control request flag, and it's up to the PC to delegate or not delegate. So we're not changing any other mechanisms in the PC stateful draft. So this is just an add-on to it to be able to control or delegate specific LSPs. So any questions, comments?
I see someone coming. I take the opportunity to just suggest that it would be good to avoid choosing the bit number you allocate. You should leave that to Ayana. You request for a bit. We had this discussion on the list, but it is still on the draft, on the presentation. Don't choose the bit number now.
All right. Yeah,
leave it for later. Thank you.
Yeah, I'm kind of related to that. So before we allocate the bits, so you started your presentation saying more operators are deploying this, which can you be a little bit more specific? If we only have as many flags as we had, and so I want to make sure that before we start allocating flags, we're actually solving real problems that operators are seeing versus technology theoretical problems. If you can maybe add some comments on your upfront statement, more operators to build a case for extra bits. Yeah.
All right. So at least from where I stand, we've seen this time and again where we try to optimize some LSPs in the network. But yeah, we will always we can probably clarify some of this in the draft, and maybe we can wait for your comments.
Okay, so I believe you have a couple of minor items to address to justify a new version. Use that new version to try to gather some support on the mailing list, and then we can see how we can progress. May I just have a show of hands on people who read that document in the room? A dozen? Okay. Among those who read, do you believe this is a useful feature? Almost the same. Yeah, maybe a couple less, but almost the same. Okay, that's a useful feedback. Thank you. Next presenter is Drew, I guess. I'm doing the head, but yeah.
Hi, this is Dhruv. This is the code point allocation. I think 2 IETF ago, we presented that and we got the feedback from the mailing list as well as during the meeting. So we have incorporated that in this version. So let's talk about that. The main idea here is that we have our PCEP registry, as we all know. The usual allocation policy that we have followed is IETF consensus, that all assignments are via RFCs, which are approved by ISG. Of course, we have early allocations, which is very useful when we are implementing and we want to get the bits set. But as you are seeing recently in the PC working group and otherwise, the experimentations that are going on with the use of PCE in various cases, we also do realize that not having some bits set aside for experimentation can cause problem. So we are hoping with this update, if we can have some bits for experimentation use for PCEP messages and objects and TLVs, so that we can start using them. The main aim is, as the experimental usage describes, is to facilitate more experiments in closed environments, and main aim is that these values will not collide with any of the other INA allocations that may happen in future, as well as the current ones. And especially now, when we are seeing PCEP also in the open source, we want to make sure that when we have features which are not standardized or who are not at the level of INA allocation, the kind of bits that we use belongs to the experimental, so that it will not create any confusion. So that's our main aim with this document. And when we saw the problem in the open source that this was happening, so that's why we are writing this draft, to solve this as quickly as possible. So what were the feedback and what's the update? We were trying to get more feedback and trying to use that what are the registries that we want to have for experimental. The kind of feedback that we got was focus only on the essential, don't try to do it for everything. So that's what we are doing. Only 3 things: PCEP messages, PCEP objects, and a generic PCEP TLV. Those are the 3 things in which we would like a small experimental range set aside. We had an appendix which was talking about what other issues can happen and what do we do with object type, notification. So we have removed all that detail from the drafts now. We were also thinking of whether there is a role of PCE working group wiki there. So again, the feedback was not to do anything like that. So we have removed that completely, and we have aligned to RFC 3692, which states that this range is only for experimentation, and the device needs to consent between each other that what is the meaning of those bits, and other implementations may use the same numbers for different users. So that's why there is no need for us to maintain a wiki, and that's the policy that we are following with this update. What's the update looks like? For experimental allocation for messages are these: for objects around 31 bits, for messages 8, and for TLVs. Allocation policy that we would like to set is experimental as per 5226. So basically we have what the feedback that we got from the last time we have incorporated, and I hope the working group is happy with that. And with that, we can hopefully adopt it and move it so that we can avoid any potential issues in this area in future. As a part of ongoing effort in ONUS, we have already started using these values for the experimental extensions so that we can avoid issues. I think that's it. Thank you.
Any comments for Dhruv?
Just was one thing.
Name, please.
Andrew Dolgan, Nokia. This is great work, very important, very needed. We probably, as in any protocol, want to add expected behavior, because you may have an experimental things added at top of the live network. So you want to describe the behavior, what happens if the receiving ends do not know how to interpret the experimental bits, not set to something. Yeah.
Luckily, I think the RFC 5440 handles all those cases quite well, like unknown messages in case it's from the experimental range, or unknown TLVs, unknown objects. So since the range is already from the not allocated, not used, so if somebody who is not following this experiment, he will follow RFC 5440 behavior.
Yeah, but then you probably at least want to say that I've quickly scanned through this.
Yeah,
for the draft.
I've not mentioned that in the document.
Yeah, I don't think it being mentioned. It's probably just worth.
Yeah.
Like there's no.
Yeah, understood.
No, just clarification.
Even if it's already covered, you may just add a sentence to point to that to make sure everyone knows we are reusing existing mechanisms, just for clarification.
Yeah,
seems reasonable.
So I'd like to know who's read the draft. Okay, I guess about 8 people have owned up to it. And of those people, who would like to see this draft adopted in PCE? That's the same people. Okay. Yeah, I think that we badly need this. It's really important. So we're going to take this to the mailing list after the meeting. Thanks, Drew. And you're up again.
Yes. So this is an update to a bunch of documents, mainly stateful HPC and the related stuff to ACTN, that how we are able to use the PC architecture and the PCEP extension so far with the stateful HPC and association objects, etc. So on behalf of all the co-authors, I'm presenting this update. Since there are a couple of documents involved here, I wanted to just show what is the relationship between these documents. We have an applicability document, which is an informational document, which talks about how do we apply the various PCEP extensions and architecture inside ACTN. And I will talk about the update to that. But apart from that, we have the various extensions that come into picture. We have the PCEP LS part, the stateful HPC part, and the VN association part. In this presentation, I'm focusing on the yellow dotted lines, but PCEP LS and even the draft which was which Stefan just presented, the state sync is also related to stateful HPC. So all these drafts, how they play a role in the ACTN, that's the document map, of which, in fact, some of the documents, as we discussed, are kind generic. They are not just for ACTN. You can use stateful HPC just as a part of your PCEP network, and it doesn't have to follow the whole ACTN architecture and CMI and all that stuff as well. Similarly, PCEP LS is just a mechanism to carry link state within the PCEP. PCEP LS is one of the, ACTN is one of the use case for it, but it's an independent work as well. The VN association is something that is kind of specific to ACTN that we have. So starting with stateful HPC, the document is pretty straightforward. It's an informational document which talks about how the HPC and the stateful PC can be merged together to form stateful HPC. Basically, it's we already have a hierarchy of PC. What if those PCs are stateful PC? Then it is a hierarchy of stateful PC. This was discussed, I think, in Buenos Aires, and we had good feedback. The kind of changes that are needed in protocol, Stefan is doing it in a generic way, so that can anyway be used in this document. So this document, that's why it's just informational. It doesn't ask for any protocol changes in the document. So what are the, I'm running through, yes, this is it. So what are the changes that we made? There were comments related to adding clarification on how the recursive nature works, and it can go to multiple levels as per the HPC architecture. So the idea is all PCEP messages, delegations, reports, updates can be done in a recursive way, similar to how Stefan presented in the state draft. The only difference is that this is a parent PC and a child PC relationship, rather than a master and a slave. How do we know? We clarified how the capability advertisement would be done. We already have a HPC capability TLV as a part of PC hierarchy extensions, and we have the stateful PC capability TLV, as well as the bit that is added for inter-PC communication. Together, we can use that for advertising the stateful HPC capability. How would we manage the state synchronization as per the previous presentation that you saw? And are there any considerations with respect to scalability, etc.? So we have tried to handle that, how that can be taken care, what kind of information that needs to be pushed up to the parent PC. So our recommendation is that we need to report only the LSPs that the parent PC could use for its optimizations, which is usually interdomain or the LSPs that he's personally involved in. You don't have to push all the LSPs from all the child PCs to the parent PC. And apart from that, the PCEP protocol allows you to have notifications and other other way to handle scalability as a part of stateful PCE draft itself, those are applicable even in stateful HPC case. And we also took care of the security and the manageability considerations as well. So we have tried to make sure that all the comments that we have received and the documents get a little bit better. So that's the update for stateful HPC. Moving on to the VN association. I think the main concern here was that what would be the use of having this kind of association within a PCEP. So within the ACTN working group, we have talked about what is a VN and how knowing which set of LSPs together form a virtual network is quite useful when we are thinking of re-optimizations or when we are thinking of how to represent a virtual network for the end user as a selection, as a list of VN members. So having this association as a part of PCEP protocol could be very useful. What are the cases? We would like to optimize all LSPs belonging to a particular VN rather than doing this per LSP. So having this kind of association, I can have a better optimization functions and better policy to handle that. And any VN specific action that I would like to perform, having this relationship between the LSPs known in my hierarchy of controllers is useful. So passing this information from parent to child is needed. So we use the association object itself, add a new association type for VN, and rest of the procedure remains the same. We added clarity to why we are doing this, what are the cases that we would need to know this kind of association, whether it is for fresh path computation or during re-optimization, where we would like to not just optimize a single LSP, but optimize the whole VN. That is, collection of all LSPs needs to work together to get the best results for the ACTN scenarios. So that's our main use case, and that's why we feel passing this information is needed. We also added a vendor information TLV support within this association object so that any vendor specific things we can pass from parent to child as well. So now this is the document that brings everything else together. It tries to say that how do we apply the various PCE extensions which are in place within the ACTN architecture. This is the ACTN architecture. It has basically some 4 functions which the MDSC and or the PNC is capable of. I will go through it in the next slide. Basically, in this document, we list in various ways in which PCEP can be used. But we also note that you don't have to use PCEP for all the functions. It's up to you. But this aim of this document is list all the possibilities, and then people can pick for one of those functions. They may still continue to use Yang or BGPLS, but for some other functions they want to use PCEP. So that flexibility could also be useful. So what are the 4 functions? The functions were multi-domain coordination, the virtualization and abstraction part, the customer mapping part, and the virtual service coordination part. Stateful HPC with the initiation functions and the per domain stitched LSP mechanism is quite useful to achieve the multi-domain coordination as well as for the customer mapping and translation. The PCEP LS part with the support for virtual networks and the various abstraction methods that we have talked in the TEAS working group can also meet the virtualization and the abstraction function of the ACTN. To map between the virtual networks and the LSPs, the VN association draft helps us to achieve this. So this is the map basically saying that how the various ACTN functions can be achieved via these extensions which are already available in the PCEP space. So what are the changes that we did? As I said, that we clarified that PCEP is not mandatory. We are not saying with this draft that PCEP needs to do everything, but we are giving a possibility that if you want to use PCEP, these are the set of tools that you should use. We also added a reference to other drafts like association policy or the state sync, as well as the various abstraction methods, so how that is applicable within ACTN context. We also got a comment to specify how does this relate to PCE-based central control. So we added a separate section that describes what is the relationship between the two. And this also handles those comments. Okay, so final slide. We want to know what's the best way to progress our documents. The main thing is that some parts are independent. They are not ACTN specific per se. So I think the stateful HPC and the PCEP-LS, they have their validity on their own. But then we have the ACTN specific drafts, which are the ACTN applicability and the VN association. So we need to figure it out as a working group. What is the order that we are progressing in, or how are we handling this? You may have seen some implementation reports we presented in the last IETF as well as there were some discussions on the mailing list where people are saying that part of what they have implemented so far. We feel that we have able to handle all the comments that we have received. Now we need to figure it out in which order we could see the work moving. Thank you.
Any comments for Dhruv?
Hi, my name is Michael Schrauf. This relates to the question that we had earlier in the morning on the CMI interface. If you go to, I think, slide number 9, where you show the, oh no, it was the one where the, yeah, that's one here. Actually, I thought that the VN concept is on the CMI interface in ACTN. Now you extend PCEP for the VN concept, but you don't show it on that interface. So this is why I said this morning, it's confusing what exactly the role of CMI is and what the VN concept is. And I think it's still unclear why you need that extension in PCEP here. Possibly this can be clarified, but I think it's an issue in the ACTN architecture as a whole. And by the way, I mean, the MMI interface is not well defined in ACTN.
I'll leave the ACTN part of it. Maybe we can focus on the PCEP.
Yeah, for the PCEP, I don't have any concern for the PCEP right now, but as I said, I think there's an unclarity in the ACTN part of this, and I think for the VN part of the presentation, it's unclear how this exactly ties into ACTN. But this is an ACTN issue, it's not a PCEP issue.
We'll handle that as a part of ACTN.
Yeah, I was going to say that sounds like a general ACTN issue. So I think probably the way we would proceed is by looking at the applicability as being sort of the primary document for now, and stateful HPCE as being sort of an independent track, and look at those two. The VN, I guess, let's get that clarified in the ACTN architecture.
That works out very well for us.
Okay. So on, just to check quickly, has anyone who has read the applicability statement? So we have about 10 people, okay. And of those 10, who would like to see the applicability statement adopted by PCE? It's about almost the same. Okay. Good. And how about the stateful HPCE? Who has read the stateful HPCE? Rather more. That's good. Okay, maybe 15. And who would like to see that adopted by the PCE working group? Okay, it's like about 10. Okay, well, that's a good start. I think we'll confirm both of those on the mailing list. Thanks, Dhruv. And next up is Julien.
Okay. So I'm proxying here for my colleague Olivier, who couldn't attend the IETF meeting this week. I'm going to introduce you a proposal about inter-domain LSP setup using the PCE stateful architecture on extensions. So I don't want to remind you all the beauty of the PCE architecture to address the interdomain problem, to provision interdomain LSPs. I just wanted to maybe put more emphasis on the specificities to the interdomain, especially inter-AS. There are very strong restrictions on what protocol can run over those inter-AS boundaries. So typically, RSVPT isn't the really considered option to enforce LSPs across AS boundaries. So there may be some use cases where the PC architecture may help, even if we don't have the RSVP messages across those boundaries. So today, typically, to address this kind of stuff, if we have two ACs in the Orange group that want to have an ESP set up end-to-end, we handle them separately, and we may stitch them possibly using some BGP mechanism there, but as soon as you want to do some TE there are some missing points. So the idea here is to enable the TE architecture to be applicable even to cover those inter-AS use cases. So the stateful BRPC is a proposal that extends the backward recursive procedure that is already defined in RFC 5441, if I remember correctly. Which allows to explore a chain of domains using the PSEP messages, having per domain PC talking to each other so as to get some multi-domain global path computation. And here we propose to extend this procedure by adding the stateful messages, namely the PC initiate message to trigger an inter-AS provisioning, LSP provisioning over a chain of ASs. The idea is to make use of these messages to trigger the missing piece between the AS, to make the glue between those AS, and get what we call in the draft a stitching level, so as to be able to agree on the label to use to carry the traffic across the AS boundary between the neighbor ASs. So it relies on the existing ERO and RO on the PC initiate message, and we propose to reuse the LSP type that has been already proposed, as we were talking with Jeff before, to distinguish between RSVP related LSPs, SR type LSPs. Here, keeping those two options, we propose to add other code points so as to cover SR for interdomain, RSVPT for interdomain, and use those code points to trigger label allocation from the ASBR of the downstream, the entry ASBR of the downstream domain, so as to get the label in the PC report and send it to PC from the domain and then up to the upstream domain. So this is probably more clear using the drawing. Supposing we have a chain of 3 ASs, each AS has its own PC. The operator comes to the first one and wants to trigger the LSP provisioning. We have the usual PSEP rec, PSEP rep exchange from the BRPC procedure that happens. We may end up with a shorter pass tree and possibly using passkey encoding to hide the detailed resource span over the downstream ASs. And based on that, the first PC in the chain trigger a PC initiate reusing the selected resulting ERO to push some provisioning to the downstream domains. On this PC initiate is relayed to the third domain here. We may end up in any number of domains. It's a recursive procedure. Back in each domain, each autonomous system is able to push its configuration down to its network node using the PC initiate to the end node. The beauty of the idea is that one AES may choose to rely on RSAPT to provision the LSP segment, while the other AES, another AES in the chain may rely on segment routing to apply the LSP configuration between its network nodes. So based on that, we have a report. The edge of the ASB of the AS3 here has identified the code points for the interior domain case. In the report, it includes the label to be used on the interior domain link between AS2 and the AS3 here. We have the label which is allocated by the downstream domain. It is reported up to the PC of the domain 3, and when domain 3 gets back to the report to its upstream domain, it relays this label to be used as interior AS glue. And when the PC2 push the state down to its network nodes, it relays this stitching label down to its nodes that is installed in the network elements. So the procedures also rely on the RO, and then up to the upstream domain, we use the same procedure, but in the upstream initiating domain, we don't need any specific LSP type, because the upstream domain doesn't need to allocate a label for another domain because it's the first domain in the chain. So we end up in a global end-to-end LSP relying on many basic mechanisms that are already defined, namely PC initiate, PC report, and BRPC procedure, and we just add the the LSP type option to trigger the stitching label allocation. So the proposal mainly rely on this draft, which should end up in RFC quite soon, because we have already early allocation pending on this. The applicability covers both RSVPT and SR autonomous system. So system remain autonomous in their T tool inside their own domain. And we also have a list of improvement to be covered for further release if there is interest on working group to work into that direction. So if you have feedback, please feel free to share it or send it by email if you prefer. Thank you.
Any feedback visually?
Yeah, Fateh from Huawei. So I think actually this draft is very interesting. So I think you are trying to make the PSIP to have the essential functionality of RSVPT, right? Which means that you are trying to use PSIP to create end-to-end connections across multiple domains.
Yeah, you may describe it like this.
So
the glue between, rather at the PC level instead of at the network level. At the network level, they are just seeing what label they use at the boundary, and they don't see the other downstream or upstream neighbor domain has a part of the LSP.
Yeah, got it. So my comment is, so can PSIP replace RSVPT totally to create end connections?
In that architecture, supposing you have segment routing enabled on all your domains, you may.
You mean maybe, right? Or
maybe, yeah, you may have it, yeah.
Okay, yeah. So another comment is, do you think that if PCE-CC can adjust your requirements if we have the PCE?
Oh, I see your point. I missed that one.
Yeah.
Maybe there are
from
some
the functionality perspective, I think it's similar.
Maybe there are some similar ideas there. I don't think PCCC solved the glue of the stitching label that we try to address here. But we may find some common grounds between both ideas, I guess. So maybe we could look at that together in detail to see if there is some commonalities to be maybe progress together. I think we need to look at more deeply at that.
So I think if there's centralized PCCC and the PCCC can send PCIP to the edge loads and to stitching the LSPs.
Yeah.
Thank you.
Yeah. Thank you, Patay.
Please be brief, Ruth.
Yes, true. Basically, I like the idea. I wanted that if SL label thing is not tightly coupled to stateful BRPC, in the sense stateful HPC may also need that kind of glue. So if we can get the label thing, and then the question is, how do we write it in a generic way? I go back to Fatah that maybe the PCCC kind of way was much more generic than this, but it's kind of needed. Other than that, I have small comments which we can handle offline, but overall this thing. One thing which I wanted to also talk about is that initiate message when it is coming from a parent PC to child PC, the relationship is kind of known, but when the initiate message goes on the peer level from one PC who's peering you to another PC, we may have a little bit more like the security issues and the manageability part. So that relationship we may have to evaluate a little bit more.
Yeah, I fully agree on that part. It's a zero version, so as you know, security is left for further study, but you're right. As soon as you touch up anything about inter-domain level, security is even something to be considered even deeper than for intra-domain.
Sorry, we're going to have to take the rest of it to the list because we're behind schedule. No, we don't have time. Sorry. Okay, so you have some feedback, Julia. We can, get some more on the mailing list, and yeah, hope that was useful. Thank you. Okay, so next it's Rakesh. Rakesh, we're a little squeezed for time, so if you could shave 1 minute off each of your presentations, that would be awesome. Thanks.
I'll try. Good afternoon, everyone. My name is Rakesh Kandi, and I'm presenting this draft on associated bidirectional LSPs with PCE on behalf of the authors listed. So we'll take a look at the requirements and scope of this document. There are two association or initiation types defined in the document that we'll have a look. We'll review the PCEP extensions proposed in the document and discuss the next steps. So basically, associated bidirectional LSPs have been deployed in the packet transport networks. In the RSVP world, the LSPs can be co-routed or non-co-routed. So the scope of the document is either PCE or PCC initiated bidirectional LSPs, and it can also be used with stateless PCE, for example, if you want to do a co-routed path computation. So in case of double-sided initiation, the PC initiates the LSP on both endpoint nodes. There is a new association type defined for it. And again, LSP can be co-routed or non-co-routed in this case. And in case of single-sided initiation, the stateful PC initiates the forward and reverse LSP on one endpoints of the bidirectional LSP. There is a new association type defined for it. There is also a TLV for the association that identifies the forward and reverse LSP, as well as can specify the co-routed flag. So as mentioned, there are two new association types defined, and the rest of the field in the association objects are populated using the RSVP RFC 75 and 51. So there is a TLV defined for the association object, identifies forward LSP, reverse LSP, or if LSP is co-routed, which can be used for path computation. So it's fairly a short and straightforward document. So we appreciate the review comments and suggestions. So is this functionality useful to have in the PCE world? It's heavily used in the RSVP in the transport networks. And if we agree, request for working group adoption.
So thanks for the question. Thanks for keeping that short. I think we need to take those questions one at a time. Before we get to the working group adoption call, I think we need to see some comments and suggestions on the draft, but we can certainly ask the first question. Who thinks that this is useful functionality to have? Yeah, like 12 people or so. So yeah, so I mean, it sounds like there's decent support for working on this. It would be good to see some comments and support on the list.
So good afternoon again. I am Rakesh Gandhi and presenting this draft on behalf of the authors. This is for the PCEP extensions for reporting the PE, LSP, PM parameters when using the stateful PCE. So agenda is as following. We'll look at the requirements and scope of the document, followed by the overview of the PCEP extensions. The EM metrics are delay, loss, and bandwidth utilization. There is also a notification message defined, and then we'll discuss the next steps. So first, to give a high-level picture of the protocol landscape, on the left side we have RFCs and drafts that deals with the those metrics for the links. Those are the IGP and BGP extensions. We also have the service-aware draft in PCE to use those extensions for the CSBF path computation. On the right side, we had those extensions for TE LSPs. So we have RFC 6374 and 7876, for example, to measure the those metrics. What's missing is that stateful PCE is not aware of those performance metrics. So this is what this draft is addressing. So basically, requirements are there is a need for the stateful PCE to know about LSP's end-to-end performance metrics like end-to-end delay and loss and bandwidth utilization. So it does do the path computation, but it doesn't have the end-to-end metric information, which is measured by the PCC. The bandwidth utilization can also be used by the stateful PCE to do the appropriate bandwidth reservation. For example, if we want to implement the auto bandwidth at the stateful PCE that does the bandwidth computation. So the scope of the draft is the PCE to request and report and receive the performance metrics parameters for both the PCE initiated and PCC initiated LSPs. What's out of scope is that how these metrics are used by the stateful PCE, and at the PCC how these metrics are measured. There are separate RFCs and drafts available for measuring those metrics. So the overview of the PCEP extensions proposed, there is a measurement capability which is exchanged in the beginning to make sure that they are capable of PM, both the PCE and PCC, followed by the PCE sending the measurement attributes request, which is responded by measurement report from the PCC. So there is a common set of measurement attributes defined for delay, loss, and bandwidth utilization, each having their own TLB types. So the attributes are measurement modes, the measurement interval, the threshold for reporting, including the count, and the threshold being absolute or percentage, and the interval, report interval. So these are common properties for all three metrics that's considered in the document. So the similar to the bandwidth object that's defined, we also defining delay and loss measurement objects for reporting those metrics. So this is the definition of the delay measurement capability TLV. There are two flags defined for unidirectional and bidirectional measurement capability. So these are the typical object formats for reporting the delay. So we have defined one-way average, mean, max, or delay variation, and similarly two-way values for them. There is an alignment of those parameters with the link attributes, the PM metrics. So we are using the same attributes as well as same types. Similar to delay, there is a capability TLV defined for loss measurement as well. We have unidirectional, bidirectional loss measurement, as well as we have infirm mode and the direct mode loss measurement. Similar to a link for loss, also the metrics are aligned with the link matrix where there is a packet loss. Is as a percentage of the total loss reported. Just like delay and loss, there is a capability TLV also for the bandwidth utilization. And the bandwidth utilization report contains a variable length TLV. There is a new object type defined for the bandwidth object. And how many samples are there in the report depends on the threshold and the interval. So there is a PCF notification message defined in order to help with scale. So if there is ever a stateful PCE getting overwhelmed, there is a notification to inform PCC to temporarily suspend the notification, and the values are defined to enter and clear the state. So welcome your review comments and suggestions. Is this useful functionality to have in the PCE world? And yes, we request for the working group adoption.
Hey, Andrew Dogan, Nokia. So the capability is useful. Would I do it that way? No, especially since I have this available today and there are mechanisms developed, designed for scale that do not overload protocol like PCEP. You can do it with telemetry, you can do it with any other things. This type of mechanisms are not scaling. That's why we're coming up with a little bit more at scale mechanisms. And over PCE has enough of the work to do to set up and react to LSPs, that overloading it with collecting performance information seems risky. And so,
yeah, the motivation is that PC is already getting a lot of LSP state information via PCEP channel. So this is just additional information that it would have everything at one place instead of having two channels or for different purpose. But that's that motivation.
Exactly saying you're overloading stuff and you're gonna get performance issues. Yeah, like if you wanna have this to really be a centralized control plane at scale, having one channel to handle a lot of things is not helping, and we breaking this purposely. So there is this is useful functionality. It's available. It can be done. I see, like, I really don't see anything new other than adding stuff in the protocol. Doing it differently doesn't mean necessarily do it better.
Okay, please try and keep your comments as short as possible. Jeff will do the last one.
But hey, speaking, could you return to the picture about the relationship?
The first one
Yeah, this one. No,
is this
yeah,
one.
this one. So in this picture, you describe the relationship between your draft and the current updates.
Yeah.
So, but you don't mention PCE LS draft, because I think actually the measurement information is part of the link information. So I think PCE LS it had very close relationship between your draft and the PCE LS.
Yes. Yeah. So BGP IGP is there. We can also add the BGP LS there.
Yeah. Okay. Thank you.
Yeah.
I'm sharing pretty much same concerns Andrew
Yeah.
expressed. So my question, do you plan to only measure performance from head-end perspective or on behalf of every node in the network?
Yeah. So this is the PCC head-end, so end-to-end performance from the head-end.
Yeah, but there's no association with particular LSP, so I presume you will be just redistributing your TET or LSDP into PCAP and showing up to the PC. Is it correct?
No, but these are initiated by PCE, right? So there is an association. I'm not sure.
So once again, you are going to send only information relevant to LSPs instantiated in particular not.
Right.
So you are missing the picture anywhere further down in the network.
If those are not directly managed by the PCE, then yeah.
They are not, but they are part of an LSP.
Right. So PCE wouldn't be aware of them and you would be missing them.
Understood. Thank you.
Jan? Who has the other blue sheet? Sergio. Has anyone not signed the blue sheets? Okay.
Hello. This is some work about the PCEP extension for the RSP scheduling. First, thanks all the authors and the contributors to this work. This is work we have discussed in previous IETF meeting, and we have received some major comments. The first is the motivation, requirements, and the use cases. We have prepared also, we have drafted a document in TIS to discuss the motivation and requirements. And finally, we get some consensus in TIS groups that we decided the architecture for this problem, and people think this is a good direction to go. So now we come up back to TIS, PCE to provide the solution. So the second question about the solution is how the PCC schedule will be synchronized between PCE and the PCCs. The answer is we use the PC report and the request and updated message to do the synchronization. And the last one is there are two drafts on the same problem, so we work with other authors to provide a merged version, which is available on the website. People can read the merged version. And there are some updates in the new version. And the most important is, yeah, two drafts has merged into the single solution for the problem we have discussed in TIS. And the extra features for this version is we add the periodical RSP scheduling from the Huaimo's draft. And also we provide a graceful period and the elastic time interval for the scheduling, which can make the people can have more choices for the RSP scheduling work. And we also add a new section for the RSP updates. What if we already have a scheduled RSP, but we want to update the information and some editorial changes. So this is the whole picture of the PCAP extension for the RSP scheduling, and this is the architecture we have decided in the teeth dropped. And in this document, we just provide some PSAP extension for the to carry on the time information between the PCC and the PCEs. So next step. So yeah, we have make some conclusion in TIS for the architecture and the problem itself. So now we come up to the PSAP to provide the extension and provide the solution. So now two jobs has been merged into the single one and a single solution for this problem. And we want to ask the group whether it's ready for the adopt.
We may get one comment if someone wants to. There's been a new update today, right, of the document. So I don't think many people have actually read this latest version. So apart from suggesting people to read that one, which is the first step to the merger of the two initiatives, which is a very good step forward. I don't think we will do more today. But thank you. I think we are right on time. So thank you very much. I hope everyone has signed the blue sheets. If you have comments on this draft or other, please use the mailing list. Try to use it as much as possible between the meetings. And we'll see each other on Friday morning for the joint young session. Thank you all. Bye.